Hi there. Just wanted to do a quick video demonstrating the injector output test mode that's available on the megasquirt EFI software. This is a 2.8 liter inline 6 running megasquirt 2 with 3.4 extra firmware on it, tuned via Tuner Studio here. I've got 6 Bosch EV14 injectors. These are factory Bosch injectors that have been modified to flow about 1200 cc's a minute. They were professionally modified, not by me. So I've just got them installed in the fuel rail, and the fuel rail pulled up out of the manifold. I want to point out that I've got the injectors installed with the retaining clips into the fuel rail here, and also the metal clips installed between the injectors and the injector hats. So nothing can come apart here. You really need to have a positive method to retain the injectors if you're going to mess around with this. If you just have an extruded aluminum aftermarket fuel rail with no injector clips, I wouldn't recommend doing this because you're just going to blow the injectors out and spray fuel everywhere. For safety's sake, I've got a big fire extinguisher sitting behind me, and I've got a electrical battery cutoff switch on the back of the car that I can access pretty quick to shut everything down in case anything goes wrong. Probably should do this outside, but it's Minnesota and it's cold, so here we are in the garage. So the way this works, megasquirt has a dialog in here that you can command a fuel injector or injection sequence without actually cranking over the motor. And this is available under the test modes drop-down menu. The section we're interested in is the Injector Testing section. So the options here, the output interval is the interval between each, or the length of each injection cycle. So an injection event will happen every 20 milliseconds. You can select which injectors that you want to fire, either all of them or one bank, or if you're running sequentially, you can select an individual injector to test. The pulse width is the actual commanded pulse width to the injector. There's no dead time built into this. And the total number of injections is how many cycles this will go through once you click the start button. So if let's say I had 5 milliseconds for the pulse width, once I click the start, it will energize the injectors for 5 milliseconds. Then they will be unenergized for 15 milliseconds, and then that will repeat 50 times. And you can stop that at any time by clicking the stop button. So what I'm using this for, I've already been running these injectors for a while, but I just want to check to make sure that they're all still flowing the same at a higher duty cycle, to make sure that I don't have one injector that's getting the filter basket plugged up inside of it or something like that. Or and I'm also testing them at lower pulse widths to make sure that they're still opening within a reasonable percentage of each other, to make sure that I don't have one injector that's getting a dead coil or something like that. This could really save you from burning down a piston if you had an injector going bad and you were able to catch it this way. Another thing that you can do here is you can characterize your injectors. If you go through all the pulse widths on this, you can actually build a chart to show the flow versus pulse width for your particular injectors at your particular voltage and fuel pressure and whatnot. You can also find the dead time for the injectors. I'll show you how you can do that here real quick. I've already tested this, so I already know what it is, but I'll set this to 1 millisecond. I'll turn on the fuel pump, and I'll click the start sequence, and you'll see it on this gauge go through the injection sequence here. But nothing happened. You didn't hear the injectors fire or anything. That's because this pulse width is below the opening time of the injectors, so the coils of the injectors are not energized for long enough to get the pintle to lift up off the seat and actually move anything inside the injector. So I'll put this up to 1.3, which is what I found to be the actual beginning of the opening of the injectors. And now when I cycle this, now you'll hear the injectors actually making a mechanical noise. But the pintle didn't actually move up far enough to start spraying any fuel through the injectors. So I'll put this up to 1.5, and now you'll actually see some fuel actually flowing through the injectors here. So this is at 1.5 milliseconds. The first 1.3 or so milliseconds is just the injector energizing and opening, and 0.2 milliseconds is the actual time that the injector is energized and open. So it's pretty impressive, really, that how well these injectors flow at a 0.2 milliseconds of injection time. I mean, these Bosch EV14s are just miles ahead of anything that was ever available in the past compared to the old low impedance injectors and the Lucas disc injectors. All that stuff is just junk compared to these new EV14 injectors or any of the new Bosch style injectors. So we'll crank this up a little bit. This car idles at something like 2.5 or 3 milliseconds. I can't remember exactly, but we'll turn this up to 3 milliseconds and we'll do 1,000 injection cycles, so you get a chance to actually see this run for a little bit. The microphone really picks up the sound of these injectors and the sound of the fuel pump, but in real life it's not that loud. Especially once the injectors are actually installed in the motor. But so now what you'd want to do if you're going to characterize these injectors is you'd want to run through a set number of cycles. Say in this instance this was 1,003 millisecond pulses, and then you would measure the volume, either the volume or the weight of fuel in these jars, and average that out to figure out what the real flow was at a 3 millisecond pulse width. And then you can go through that and you can characterize the injector and you can build a flow table or flow chart of these injectors. Keep in mind too that the car is just sitting here on a battery charger. With one fuel pump running, it runs at about 12.5 volts. Once I turn on my second fuel pump, it dips down to closer to about 12 volts. So if you wanted to test this in more real world conditions, you could hook up the car to a jumper cable to a second running car to get the voltage in the system up to 14.5. This isn't really an accurate test without the running voltage in the car, because then the dead times will be different and the pump voltage will be different and all that. Let's turn this up a little bit. So we'll go to a 10 millisecond pulse width. So this is a 50% duty cycle here. I'll turn the number of injections down to 50. See what that looks like. 10 millisecond duty or pulse width. This is about a 50% duty cycle. And if you wanted to test it at a lower frequency, you can increase the output interval. I'll turn it up to 50 milliseconds. Alright, so let's see, I'll turn up the wick here a little bit. I'll turn on my second fuel pump so we can get all the fuel full we've got on tap here. I've got two Walbro 255 inline pumps in the trunk. So let's see here. We'll turn this, we'll do a 15 millisecond pulse. Turn this back down to a 20 millisecond interval. So this will give us a 75% duty cycle. Just to focus here. You can really tell the difference once we got both pumps running. Alright, so another thing you can do here, once you're satisfied that these injectors are flowing within a range, an accurate range of each other. I've tested these at a bunch of different pulse widths now, and these particular injectors, I can't really tell any difference in flow at any measurable pulse width. They're within the accuracy that I'm able to measure anyway. But another thing you can do if you wanted to test the static flow rate of these injectors, so just holding the injectors wide open, if you set the pulse width to the same amount as the output interval, that will just hold the injectors open for a set number of cycles. So in this case, it would be 50 20 millisecond cycles. So that's 1,000 milliseconds. So that'll hold the injectors open for 1 full second. So see what that does. So if you wanted to test the static flow of your injectors, you could set this up so that it injects for, say, like 5 seconds continuously. And then you can measure that volume of fluid and multiply that by 12, and that would give you the volume or weight of fuel per minute that these injectors flow at, whatever your flow rate or whatever your pressure is. This is a 50 psi base pressure, and fuel is E85 here. Another thing that this is really handy for is you can kind of test the rest of the fuel system to make sure that it's actually up to par to be able to flow or to keep up with your injectors. So for example here, I've got pressure gauge set on my fuel pressure regulator, and I'll run this for another 1 second cycle at static flow. We'll watch the pressure drop on the regulator here. So that dropped 10 psi once the injectors opened. So what you'd really want to do here is you'd want to measure this under the actual operating conditions, the worst case operating conditions that you'll see. This is a turbo car, so once that guy makes about 30 pounds of boost, that'll add 30 psi of pressure onto the pumps. So the fuel pressure at 30 pounds of boost will be 80 psi. That puts a lot more load on the pumps, so the pumps don't flow quite as much at that high pressure. So what you'd want to do is bring the system voltage up to 14.5, which would give you the full power from the fuel pumps. They'll have a lot more power at 14.5 than they will at 12. So bring the system voltage up to 14.5, and then you want to crank that pressure regulator up to whatever your maximum fuel pressure is at full boost. So in this case, I would crank the pressure regulator up to 80, and I would repeat this test to see if the pumps can actually keep up with the injectors under full voltage and full boost. So that's another really handy thing. If you're concerned or curious if you have enough fuel pump for your setup, you can test it using that method. That's a lot better method to test than just looking at the flow maps of the fuel pumps. I've tested a lot of pumps, and once you put a pump in a car and you run it through 20 feet of fuel line and two filters and a fuel rail and to the regulator and all the way back to the tank and whatnot, the pumps never flow anything like what the charts from the manufacturers say that the pumps are supposed to flow. It's usually like 75% of what the pump is optimally supposed to flow. So you just take that whole equation out of this and just test it in the car, and then you'll really know for sure. But so yeah, pretty handy feature. I mean, if you were to catch a bad injector this way, you'll save yourself a piston. Also save yourself a whole lot of messing around wondering whether you've got an adequate or enough fuel system. You can tell for sure. I think this is a really cool setup that they've got here. I really like it, and I'll probably use it quite a bit in the future. Well, I guess that's all I really got to say about that. Be safe, have fun.